Hello, everyone, and welcome to Talk Nerdy. It is Monday, September 12th, and I'm your host, Cara Santa Maria. I missed you guys last week. I thought it best because of the Labor Day holiday. I wasn't sure who'd be signed on, and I was traveling like crazy. I was in Atlanta for Dragon Con. Woo! That was a roller coaster with the Skeptic's Guide guys. Lots of fun. Did my full-on Star Trek garb. I think I may be being turned to not the dark side, because that's the wrong franchise, but the geeky side maybe a little bit. Anyway, lots of fun, but I did miss you so much. I am really excited about the episode this week, but before we dive in, I want to thank those of you who made Talk Nerdy possible by rating and reviewing across platforms like iTunes, by visiting the Talk Nerdy store at carasantamaria.com, and by pledging your support either through the PayPal portal or by visiting www.patreon.com/talknerdy. The patrons this week who have earned a shout out are Phil T. Bear, Pedro Rosario Barbosa, Stuart Ogg, Atomic Rod Adams, The Honorable Husband, Charles Payette, Jafe, Gabriel Felipe Jaramillo Gonzalez, Brian Holden, and Jeffrey Sewell. Thank you so much from the bottom of my heart. You make Talk Nerdy possible week after week. All right, guys. This week, I sit down with the Mathemagician himself, Dr. Arthur Benjamin, and we talk about his newest book, The Magic of Math, Solving for X and Figuring Out Y. And he also amazes me with some very cool tricks involving mental math. I learned a thing or two myself as well, and maybe you will. So without any further ado, here he is, Art Benjamin. Arthur, thank you so much for joining me today.
My pleasure.
And you typically go by Art?
You can call me Art.
You go by Art.
On paper, the books, they say Arthur, but
sure.
We're new friends, so you can call me Art.
Well, Art, thank you for joining me. Art, of course, Arthur Benjamin is the author of The Magic of Math, Solving for X and Figuring Out Y, which is a very fun title. And many other books about math as well, right?
Sure. My most popular one prior to this one is called Secrets of Mental Math, which teaches you how to do math in your head faster than a calculator.
So crazy. So I was just watching your TED Talk one more time, in which you call yourself, and I know the moniker has stuck over the years, obviously you can even see it in the cover art of this most recent book, The Mathemagician, which is such a fun play on words.
Thank you.
But also makes perfect sense for the type of math that you do, but also the types of tricks that you teach people how to do. And I would assume that you've perfected over many, many, many years, because as most magicians will tell you, the real trick to magic, other than sort of the sleight of hand and the playing tricks on people's cognition, is just practice.
Oh, yeah. To get good at anything, of course, whether it be magic, math, music, academics, sports, it's so much of it is about putting in the time. For me, it was very enjoyable time. So I've always enjoyed magic. I've always enjoyed math. I've always enjoyed entertaining people, communicating the ideas that I love, just like you. And so it was just a natural combination.
Was it a chicken and egg situation? Did the math come first? Did the magic come first? Or did they sort of come together?
They came, I would say, independently in that for as long as I can remember, for as long as my mother and father can remember, I always liked math. I liked numbers, puzzles, patterns. I was raised in a somewhat theatrical family, and so was put on the stage at an early age and developed a love for magic, like most kids do. But I didn't really outgrow it, and I continued to do it into middle school and high school. In high school, I started doing magic shows for children's birthday parties. I was the great Benjamini, doing magic throughout the east side of Cleveland, Ohio. I did, and it was just your traditional kids magic show, the rabbit out of the hat, falling on my tush, making the kids laugh. And then as I started doing shows for older audiences, I switched into doing some more magic of the mind. And my father said, well, why don't you put some of that math stuff that you do, I find that to be, even more impressive. Why don't you put that into your show and see how it works? And even though it wasn't a trick, it was a bona fide skill. I tried it, and much to my surprise, it got the best reaction of the show. Probably because it's genuine, and people couldn't see how that would be done by trickery. And so that got all the attention. And so over time, I've practiced further. I did bigger problems. I did them faster. It got all kinds of attention and interviews, and it just took off from there. So I've been a mathemagician since about the time I started college many years ago.
I love that. And so a lot of the tricks, quote unquote, that you do, like you said, these aren't tricks. They're not a sleight of hand. They're not some sort of way to, distract somebody away from you,
right.
Tricking them. It's a bona fide skill. You're doing very, very fast calculations, utilizing a lot of ingenious shortcuts.
Yes, exactly. So I'm not doing... the way I'm doing the math in my head is not the way that you would do it on paper. For one thing, and if there's only one thing you remember from everything I'm going to say today, it's that I do all of my calculations from left to right. As opposed to the way we do it on paper, where we're taught from right to left. On paper, you first come up with the ones digit, then the tens, the hundreds, the thousands, but that's backwards. We read the numbers left to right. We pronounce the numbers left to right. So with a little practice, you can and should calculate left to right. And it's more important to know the numbers on the left than the numbers on the right? You'd rather know that the number is around 20,000 and something instead of knowing that it ends in 7.
Yeah, it's much more precise if you round it to the thousandth, to the not the thousandth place, but the thousand place,
right,
than if you were to round up just the,
if you're doing it the way they teach you in school, you first come up with the ones digit, then the tens and the hundreds, and by the time you've likely made a mistake is when you're coming up on the most important numbers.
That's true, and you almost don't have the wherewithal to know the difference, to be like,
that's right.
How is it that I'm a whole order of magnitude off?
That's right. I mean, for example, here's something they don't teach you in school. I mean, let me say something directly to the audience, see if they could figure this out. Like if you divide a 10-digit number by a 3-digit number, how many digits are in the answer?
I have no idea.
I know. And that answer is that it's 7 digits or maybe 8 is more important than knowing the first digit of the answer or the last digit of the answer. You want to know that the number is in the tens of millions or hundreds of millions, or the ones of millions, right?
Yeah.
So and why is that? Okay, well let me tell you. So like if you take let's do multiplication first. If you take a 3-digit number times a 4-digit number, how big is the answer? The answer is it's 7 digits, 3 plus 4, 7 digits, unless the product is a little small, in which case it could be 6 digits.
Gotcha.
Right? And that's it. The division is even easier. If I take a 10-digit minus a 3-digit number, then the answer is 10 minus 3, 7 digits, unless the first digit of the beginning number is bigger than the second digit of the smaller number, and then you add 1 to it, in which case it would be 8 digits.
It bumps up a little.
Way more important to know that.
So much more important. Imagine going to the bank and they incorrectly give you change. Wouldn't you rather them make a mistake in the pennies or in the ones than in the thousands?
Absolutely. So here, let me give you a quick little demonstration just to get us started, because we're sort of talking in the abstract.
Sure.
But I'd love your listeners to hear a little bit about what I do, and then you'll have many questions, I'm sure. So I see you brought a calculator with you.
Of course, how could I not?
Well, you have your phone, so you have a calculator.
Yep.
So let's start off easy. Give us a 2-digit number. Just say a 2-digit number.
71.
And another 2-digit number.
19.
So if you multiply 17 times 19, you should get 1,349, right? 1349.
Yep. 1349.
There
Yep,
we go.
71 times
All right.
19.
Now, my specialty is squaring numbers. That's taking a number times itself.
Mm-hmm.
And your calculator probably has a shortcut for squaring numbers. Maybe
Okay.
if you turn it on its side, you'll see the little x squared button.
I do, yeah.
So let's start off small with a 2-digit number. Say a 2-digit number.
35.
Squared is 1,225.
That is true.
Let's do it. Those are too easy. I've done those for
Oh,
too many
okay,
decades.
okay.
Let's do some 3-digit numbers. I don't have those answers memorized. I
Okay.
really have to calculate them. Go ahead.
Let's do 684.
684 squared is 467,856.
By the way, guys, he is just sitting here with nothing. He has no calculator. He's not holding a pen in his hand. He's just doing this in his brain. I'm freaking out. Okay.
Let's do another 3-digit number.
one.
That was
All
good.
right,
That was
all right. 423.
Okay, 178,929. And again, let me say, it looks like I'm getting the answer instantaneously, and yet I am calculating it, and I am starting with the numbers on the left. And as I'm saying the 178,000, I'm still calculating the 929. That's another reason why it's good to work from left to right. You can start to say your answer while you're still calculating the rest of the answer.
It's going to cut into your processing speed if you do it opposite, because not only do you
That's
have to figure out the end before you can start speaking the beginning, then you have to remember to transpose it all.
I can even start to when the problems get really big, like we'll do a 4-digit number in a second, I can actually, for my performances, I can actually forget the beginning of my answer because once I've said it, it is out of my memory, and I can free up valuable memory space for it. Here, let's try a 4-digit number.
Okay.
I will write the 4-digit number down.
Okay.
That'll help my memory. But otherwise, I'll calculate it in my head.
Okay, let's do 8,621.
All right, that's a tough one. Here we go. 74,311,641.
You were so close.
Oh gosh! Oh no! I got to figure out what I did wrong. 143, 178. Oh gosh! I may still be getting the same answer. 311,641.
321,000.
Forgot to carry the 2.
Oh, it's so good.
I
can't believe it, though. Okay, let's try another one.
Let's try another
one.
one.
All right.
Sure.
Okay. I'm glad I picked a hard one.
Yeah.
I don't even know why that was a hard one. Maybe you can explain
Well,
that to me.
I'm still in my head trying to figure out where I see it now. Okay, go ahead.
See it now? Okay. Let's do...
I did 178 plus 143 and got the...
I'm already lost as to why you would be doing
I know. Well, that doesn't make sense. All right, go ahead.
All right, cool. Is it good to include zeros, or does that
that makes it easier on me. So I will say don't put zeros.
Oh, interesting. Okay. All right. Let's do 3,625.
Okay, here we go. 13,140,625.
Wow, that was really fast.
Oh,
that was
good.
Perfect. Yeah.
Shoot. Fast and correct.
Fast and correct.
Is better than slow and wrong. Okay,
it's interesting
that's
because
good.
I think the mistake was in the 10,000s digit.
That actually makes sense.
Yeah?
It's usually in the middle of the problem. The numbers at the beginning, I'm usually very good at because of the fact that I'm doing it left to right.
Yeah.
And the numbers at the end of the problem don't get added to anything.
Okay.
It's the numbers in the thousands where I have usually 2 different 3-digit numbers to add in my head. And if I'm a little bit out of my element, not standing up on a stage, but here in the studio, then I'm more inclined to make mistakes.
On a Saturday afternoon. Yeah. So first of all, when I would do a problem like this, it would take me minutes and minutes, and it would fill up a whole page.
Right.
Because I'd be having to do, and then carry the this, and then work on the next line, and carry the this, and work. I mean, 4 digits times 4 digits alone is a lot of work.
Right.
So you are doing this at lightning speed, like within seconds.
Sure.
And-
But you wouldn't, once I show you how I'm doing it, then it would become much easier for you as well.
Really?
So let's try some squaring of 2-digit numbers.
Okay.
And I'll put you on the spot.
Oh,
so
no.
now you get to do math in the studio. Okay. So give us a small 2-digit number as a first example.
12.
12. Okay, that's a good
small
one
number.
because we all know the answer to 12 squared, right?
do?
It's 12 times 12 is
We know that?
144.
Well, of course,
It's
144.
It's gross, but that's the answer. Okay. So now here's how you would use my process
Okay.
to square 12. Okay, now 12 is not a bad number to multiply, but what number near 12 is even easier?
10.
10. So I'm going to go down 2 to 10. Now, if I go down 2 to 10, I have to balance it by going up 2 to 14.
Gotcha.
All right? So if I went down 2, I go up 2.
We're talking
Now,
like down on the number line, up on the number line.
yeah, exactly.
2 minus 12
That's
minus
right. If I
2,
start with
plus
12 and I go down 2 to 10, then to balance it, I have to go up 2 to 14.
Okay.
Now, what's 10 times 14?
That is 140.
Great.
That's
and
easy.
you're almost there.
Okay.
All you have to add to this is the square of the number that you went up and down. You went up and down 2, and 2 squared is
4.
4.
Yeah.
So there's your answer. 140 plus 4
interesting.
is 144.
Okay.
Okay, so that's not so bad.
Yeah, that's not so bad.
So let's say you were doing let's another easy problem. We'll do the same way. Is let's say the number ends in 5.
Yeah, okay, we like that.
let's say you were squaring the number 35. Okay, so now the nearest easy number is
30.
30. Okay, so and if we go down 5 to 30, we have to go up 5
To
to
40.
40. And then we do 30 times 40, which, if keep track of our zeros, is 1,200.
Yeah.
Almost there. All you add is the square of 5 because you went up and down 5.
25.
5 squared is 25. So what's the answer?
1225.
1225. Okay.
Oh, neat.
Here, let's do one last one. I'll give this one for your listeners and give them a minute. Well, I'll give them like 10 seconds to figure it out.
Okay.
And then we'll go through it. So try to square the number 97.
Ooh, see, these get hard for me.
I know. Well, the thing about this is it looks hard, but it's not so bad.
But I'll tell you one little probably annoyance, and I'd be interested to hear as a professor and as a mathematician what you think about this. I, as a child, was very petulant, and I refused to just memorize my multiplication table. So I don't have that base knowledge like most people do, where you can just say, what's 8 times 8, and you just know it, right? Because I realized that I could learn up to about 5, and then I could just double them all.
Or something like that.
Exactly. I realized, like, I don't need to know, let's say, 7 times 8, because if I know 7 times 4, I can just double it to 7 times 8. And so, in a way, I was actually learning procedural math.
Which is great.
But it shortens my quick.
Yeah, that's right.
Calculation time.
I love the fact that you came up with procedures and that you said, hey, I don't need, if I know 7 times 4, I can derive 7 times 8. I could double that 28 and get 56. But the bigger that base of fingertip knowledge is, the more fluid and fluent you're going to be. And so though I applaud your petulance and your creativity, I think you do need to, or at least maybe not you anymore, but our children need to memorize their multiplication tables
And that's
through
the base
10.
Up to 10. Okay.
They don't have to. I will show you shortcuts on how to, like once you know your tables through 10, there are clever shortcuts for multiplying, let's say, any two numbers between 10 and 20.
Gotcha.
And there are clever ways of squaring numbers or multiplying numbers that are close together. And I talk about these in my books.
Sure. And do you use them, or does somebody like
do.
yourself have a base multiplication knowledge that goes up to like 50?
I only have my tables memorized through 10.
Interesting.
Some numbers have come up just through frequent enough
like
use.
11s and 12s.
Yeah. Oh, they're tricks for 11s. Let me show you how to do 11s. But I don't want to leave the audience hanging.
97.
We're still squaring 97. But then I'll show you how to do 11s and other great things. So 97, I've given everyone enough time to try and work it out. What's the nearest easy number?
100.
Yeah, so I'm going to go up 3 to 100. So I go down 3 to
94.
94. 94 times 100 is
9,400.
and all we have to add is the square of
3, which is 9.
Yeah, and so what's the answer?
9,409.
Got it.
Wow, that's so fast.
So you did that in 10 seconds.
Yeah, that's really
and
fast.
And with just a little bit of practice, anyone can do these problems. And now once you get good at squaring two-digit numbers, but only after you get good at the two-digit numbers,
then you
can then build on
knowledge.
3 digits, 4 digits, 5 digits, and so on.
And so it is really cool because I notice what you're talking about where you can almost forget the original number you're squaring and forget the first couple of digits once you verbalize them in your trick.
That's right.
And you've moved on to the number of units away you
That's
are.
right.
And squaring the 3,
That's
you're
right.
like, oh, I'll just talk
Once
about
you've
that
said the 9,400, you can just focus on the
Yeah.
square of 3 and get 9, and you've said the whole answer.
Interesting. So you mentioned a shortcut for 11. I remember learning a shortcut for 9 on my hands.
Oh, yeah.
You know the little trick where it's like 9 times 3 and you
And you bring
bend
down the
your
third
3,
finger and you look on your
27.
fingers and you have 2 to the left of that finger and 7 to the right, and there's your 27.
And it's a really visual way
Yeah.
to manipulate the numbers because you have this base of 10 fingers.
And it teaches you something about the multiples of 9, which is something that actually mathematicians use all the time, is the fact that every multiple of 9, at least 9 times 1 up through 9 times 10, the numbers, the digits, add up to 9.
That would
like
make
9
sense.
times 3 is 27, and you can not only can you see that by looking at 2 plus 7 is 9, you could look on your hand and see, oh yeah, there are 2 fingers to the left and 7 fingers to the right, so that's 9.
'Cause one is
that
down.
you could see if you're putting one finger down,
Yeah.
it's always going to be a total of 9.
That's cool. You just suppress a single digit when
That's
you
right.
do your 9.
And literally a digit. And that's where the word digit comes from, of course, is because that's from our hands.
Which is, of course, why scientists often get so frustrated by the fact that we don't use the metric system
Yes.
across the board in the United States. We use it in science all the time, but we don't use it in general parlance, which makes no sense. The metric system is so easy to work with because it's all in units of 10.
That's right. That's right. It is ultimately the simpler, the faster system. You know, even if the world could adopt a new name system for numbers, we'd be better off. I mean, the best naming system belongs to the Chinese.
Interesting.
That is, if you they don't have numbers that are strange like 11 or 12 or 98. They have numbers that, which is like 4 times 20 plus 18 is how they say 98 in
That
French.
is crazy.
Right? So whereas in
Spanish is good.
But it's not as good as Chinese because in
Interesting.
Chinese, after you've counted through to 10 and all of them have quick one syllables, there's no like sevens in there.
Gotcha.
Then the numbers after that, if you translated them, would be 10 and 1. 10 and 2.
So instead
10,
of saying
3.
11, we'd be saying 10D1.
We'd be take 10D1. Exactly.
Yeah.
You know, if maybe not even the D in the middle, which is 10-1. You know, the 27 is 2-10-7.
That's true.
And-
because even our single digits with 7, most of them, 1, 2, 3, 4, 5, 6, 8, 9, 10 are good, but 7 has
7's
2 digits.
weird,
It's weird.
And I remember reading that the Chinese kids can count to 10 faster in their language than we can count to 10 in ours.
Because they're all single digits.
They're all
very
single
quick.
syllables, and even the I don't remember all the Chinese syllables. Sen sa wu, is they're simple numbers to say.
They're nimble.
Nimble. Like 4 takes maybe longer to say than.
That's fascinating. And you know what? I wonder if there's any correlation there between the teachings, the old teachings of how to use an abacus, the way that they say the numbers in their minds, because those abacus competitions that you watch where they're air abacusing.
Yes.
They're amazing.
And that people have theorized that is one of the reasons, perhaps, why kids from Asian countries have a little bit of a leg up in math is because in some ways the the language has made their job easier, and in the same way that metric would make everyone's job easier if only we would all adopt it.
It's funny. It's obvious that in a universal sense, numeracy came first. In a universal sense, numbers kind of exist without names, right? There are quantities that exist in nature. But for whatever reason, in certain cultures, the idea of symbolic interaction, the idea of naming the things around you predated the numeracy.
That's right.
And then that became a conflict.
That's right. Numbers were a concept before we had the ability to write them down or give them names.
Yeah.
Yes, exactly.
That's fascinating. All right. So you mentioned a shortcut for 11.
Oh, good. Thanks for reminding me.
course.
So let's say, all right, give us a small two-digit number, and we'll multiply it by 11. This is
small
one,
two-digit
This
number.
is one that this is one I like doing if I have like elementary school kids, because
fun.
they are they can do this one. Even
yeah,
a
and
second
because they
graders
know
can do this.
their multiplication tables.
I
at
might
least at the
say,
beginning.
yeah. Well, no. Even if they don't know their
cool.
multiplication tables, because and I'll say to an elementary school audience, even if you don't know your multiplication tables, you can multiply any one-digit number by 11 because it's very easy. 3 times 11 is 33, and once they hear that, they know what to do next. 4 times 11, 44.
Yeah.
Exactly. But now I'm going to show you how to multiply any two-digit number times 11. Give us a small one to get started.
24.
24 is as easy as 2 plus 4. 2 plus 4 is 6, and there's your answer, 264.
Oh, shut up.
Yeah, I know.
That's so cool.
And it is so cool. Why aren't they showing that in school? I mean, there are some creative teachers that do, but that should be the sort of thing that makes kids feel empowered.
For sure.
I can do something my parents don't even know.
Oh
Here,
my
let's
gosh.
53 times 11. 5 plus 3 is 8. So the answer
583.
exactly.
That's so cool. So anytime the two digits are small enough that they don't go past 10.
Good point.
It works. Okay.
Now, what if they add up to a number that's 10 or bigger?
Yeah.
Like, let's say we had 85 times 11. Now, 8 plus 5 is 13, and the answer is not 8, 13, 5.
Yeah, because we're, again, an order of magnitude up.
As you know. But the 1 makes the 8 carry.
Okay.
And so we just put the 3 in the middle.
Okay, so 13 still, but we just take the 3 from it.
Yeah, that's right. And the 1 is used to make the 8 carry.
So it becomes
It's
935.
Exactly.
Wow, that's
right?
so
Here, let's do
smart.
everyone one last one. 77 times 11. Think about what it is. 7 plus 7 is
14.
So the answer is
847.
Exactly.
Oh my gosh, that's so. I just did that so fast, and you don't understand. This is like the bane of my existence that I'm terrible at mental math. I am your direct opposite. You wow people with how good you are at mental math. I will be an embarrassment at a dinner party because I'm educated and I am academic, and yet my mental math skills are so elementary. I struggle so much with it because I don't know any of the tricks, any of the shortcuts. I'm limited by my multiplication tables.
And yet, let me make the point that just because you stumble with arithmetic, it is not a major obstacle to learning and loving science.
Yes.
Right?
Oh,
And
it's so true.
That is the math that mathematicians do and that scientists do is really much more conceptual. And
You're
using algebra, and it's using some trigonometry.
Or
maybe.
For me, it was a lot of statistics.
Statistics is, I love probability and statistics. And that's that's so just because you felt that, you never could memorize your multiplication tables and you always, you struggled with long division or fractions, doesn't mean you can't do math. On the other hand, the better that experience is for you, if you have a very positive experience with arithmetic, that's going to make you go into the next round of mathematics, algebra, geometry, trigonometry, statistics, with a much more positive attitude. So I would say to parents of elementary school age kids, make sure they memorize their multiplication tables through 10, because frankly, what are they going to fill their heads up with anyway? That's a good thing to have in your hardwired knowledge as your multiplication tables through 10. You don't have to make it drudgerous. You could make a game out of it. You could have fun with it.
And there are tricks for some of them.
And
You know,
there are
the
tricks,
fives
the
obviously are
fives,
fun. The nines are fun because you can learn these little secrets behind them.
I believe in, once you've learned the threes and fours table, you actually are way beyond halfway done. So if you can learn how to count by threes quickly, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and you say it faster and faster, and you do that with the multiples of 4, then you learn how to say it fast, learn how to go backwards, learn how to then identify 3 times 1, 3 times 2, 3 times 3. As a kid, I would memorize silly commercials that had no, 2 all beef patties, special sauce, lettuce, cheese, pickles, onion, a sesame seed bun. If I could learn that, I could learn 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Right? It's the same amount
And
of.
that's true. Those are the little speed bumps, 3s and 4s, and then I would say probably 7s and 8s.
But once you've got the 3s and 4s, and as you said, 5s are easy, and 1s and 10s are trivial, and there's a trick for 9s, then all that's left are 6, 7, and 8. But guess what? Most of those are being multiplied by 1, 2, 3, 4, 5, 9, and 10, which are easy. So it's only 6, 7, 8 times 6, 7, 8. That's only 6 problems that need to be memorized.
And I think that's where I said, well, why would I do that if they're just multiples of, 6, 7, 8 are just multiples.
But bite the bullet,
3, 4,
learn that 7 times 8 is
do
56, and you'll
I love that because then you have a much bigger base.
Exactly.
And I struggle. And I think that the unfortunate thing is I was a standard kind of casualty of the educational system. And hopefully with Common Core, it's actually improving a little bit. But I don't think I ever had that inspirational math teacher. And I think that if I was taught math in a more sort of like linguistic or like numeracy way, it's about becoming fluent in numeracy. I didn't have that opportunity. And because of that, when you don't have the foundation, everything's building on something that's crumbly.
Absolutely.
Yeah.
Absolutely. That's why it really is important to have a good grasp of the foundation, of the fundamentals. And a good teacher just makes all the difference. I mean, it can make an enormous difference in your confidence level in math and your ability. And unfortunately, a bad teacher can really have a big negative impact on your life too. But what I tell students who, whether they high school or college age students, I say, don't let a bad teacher ruin the rest of your life. It's bad enough that you had to experience that bad teacher for a year. Don't let them, take away one of the most important subjects to learn for your future career prospects.
It's true.
It's bad enough that they made 1 year difficult. Let's not give them any more years than that. And yes, it might mean go back, get a tutor, get some help. No shame. We all run into the wall. In fact, the book that just came out is on the magic of math. It covers all of that middle school and high school level math, whether it be algebra, geometry, trigonometry, but it's filled with tricks to help you appreciate and enjoy the mathematics so much better. Here, I'll give you an example. Here's how I start the algebra chapter. It's with a magic trick. Most of my chapters begin with a magic trick of sorts. So I say, okay, think of a number between 1 and 10. Okay. All right? Don't say it. Okay. Just think it. All right? It could be larger, but it'll make your math easier if it's between 1 and 10. All right? Now double that number. All right? Now I want you to add 10 to that number. Whatever you're thinking of now, I want you to divide it by 2. Okay. And finally, I want you to subtract the number that you originally started with. I'm
trying to remember. Yes.
Okay, good. And so right now, I think you're thinking of the number 5.
How did you? Oh, they all equal the number 5.
Well, yeah. So it's not a wonderful magic trick because, in about this time that it took you to say, oh, it must always be 5. But I'll bet you're wondering, but why is it the number 5? Yeah. Why must we get 5? So that is the beginning of the algebra chapter because that's what. So I'm going to try and do this even for your radio listeners, podcast listeners. So the whole idea of algebra. Let me tell you a story that my father told me. He said, "Son, Algebra is just like doing math with numbers, but instead you're using letters. And we add them in very similar ways. Like if I said 2x plus 3x, you get 5x. And if I said 3y plus 4y, you get 7y. Then he said, okay, so Arthur, tell me what's 5q plus 5q. And I said, 10q. And he said, you're welcome. Because that was my dad. He was more interested in making bad puns than teaching us math. But I say that because now I'm asking you to think of a number. Now, I don't know what number you're thinking of. Let's just call that number n, as in number. And already we've taken the most important step in algebra, which is letting a letter, what we call a variable, take the place of an unknown quantity. Just that leap alone is what most of what algebra is about. So, I mean, that's how computers can run and solve, can make your bank transactions. No matter what numbers you put in, it knows how to handle them. Okay, so you started with the number n, and then what did I tell you to do? I said double it.
Okay.
So now, if you double the number n, you have 2n,
Yep.
right? 1n plus 1n is 2n. Then what did I say? I said take that number and add 10 to it. So now we have 2n plus 10. Then I said take that number and divide it by 2. So if I take 2n plus 10 and I divide each of those by 2, I now have n plus 5. And then finally I said subtract the number you started with. And what number did everyone start with? N, right?
Yeah.
The abstract concept, n. And if you take n plus 5 and you subtract n, all that's left is 5. So in one magic trick, we have already started learning about manipulating variables. And you get your students, your class, after you do the magic trick, their first question is, how did you do that? Now, a magician doesn't tell you how you do that because it would make the magic trick less mysterious and amazing. But a mathemagician actually thinks that the secret is even more amazing than the magic trick itself. So now that they're invested in why does this work, then they can see why. Right? As in the title of my book, it says The Magic of Math, Solving for X and Figuring Out Why. It's that why is this working that makes math so magical, in my opinion.
And there are so many of those fascinating whys within math. The
That's
more
right.
you dig and the more
That's
that you
right.
have a great teacher who kind of can help you uncover those things, the more you go like, holy crap, this language. And this is why I think there's so many religions that utilize like numerology. And there's so many cultural things that are sort of view math in a more sacred way. And that's because there's this fundamental underlying universal organization that almost makes you go like, what came first, the math or the brain that could then understand the math?
True.
You know what I mean?
I mean, certainly they've done experiments that show some animals seem to have a concept of number, that crows seem to be able to keep up to maybe almost, 10 or at least 5. They could sort of count, how many people went in the barn and came out, and is there anybody still left in there? I mean, it's pretty amazing.
It's very cool.
How that comes about.
I love that. It's and that's really the case for almost every type of math, isn't it true? Because every type of math, especially as you get to higher and higher levels, really it's about the numbers representing fundamental processes in nature.
Well, I mean, let's take the most famous theorem in mathematics, certainly in geometry, is the Pythagorean theorem that says if you have a right triangle and one of the legs has length A and the other leg has size B, then the third side, the hypotenuse, the one that's on the other side of the right angle, has the property, if we call that C, it has the property that A squared plus B squared is C squared. So one rule works for no matter how long the first leg was and how long the second leg was. We have an exact formula that'll tell you what the length of the third side was. But what I find to be, and so that's a theorem that's very useful. It's used all the time in mathematics and science and engineering. And yet what really separates math from all the other sciences is that we can prove why it's true. In every other aspect of science, in physics, we say, well, why does gravity work? Well, it's just a fact of nature. It's just something we've observed and enough times that we can be sure that it's going to, we're practically sure that it's going to work because of what we've observed out there.
And
whereas
we
in
know
math,
too that it doesn't always work that way. Once you get into the very small or the
That's-
very cold.
Well, that's
or the
right.
Very, yeah.
That's right. That's right. The gravity, which works for apples and planets, isn't really working the same way for electrons.
Nope.
And so you might have thought so until you started observing their behavior, and then you had to modify the rules. But the Pythagorean theorem, that's going to be true for triangles from now on through history, to the end of time. On the other hand, mathematicians might say, well, yeah, but that's if you draw your triangle on a flat table. But what if you drew a triangle on the surface of a ball or on the earth or something? And now, and rather than mathematicians saying, shame on you for asking that, they embrace that. They say, that's great. Yes, we might have to come up with some new ideas and new mathematics for these new situations.
It's funny. Math is so positive. Geometry, that's what geometry is. It's proofs.
That's right.
You can prove why this happens, whereas in science, all you can do is disprove.
In a
you
way.
You can't prove.
That's right.
You can only reject the null hypothesis.
You can say things like, well, we can say that this is a virtual certainty just because it is consistent with all of these mountains and mountains of evidence, whether we're talking about gravity or evolution. We just say, look, it just has to be true, or else, my gosh, we're in big trouble.
But if I say this proves that, there will be one example in which it doesn't. So it's so important in the sciences specifically to say things like, this research has disproven the idea that X leads to Y.
Right.
We now can say with assurance that X does not lead to Y, but I can't ever fully tell you that X leads to Z. Whereas in math, you can.
But and so when they want to say that, they say, well, look, if we accept these mathematical assumptions. If we assume, for example, that that the force between two objects is inversely proportional to the square of their distance, then it follows that these planets should have an elliptical orbit and things like that. So, but you have to say, assuming, these are like our axioms, our assumptions, assuming that this model works, then we can reach all these other kinds of conclusions.
Yeah, because then I'm not accommodating for the hidden Death Star, or the thing that's there that could mess up the model. There may be
some other kind of universe, or maybe in the universe of the very tiny or something that maybe the force is not proportional to the square of the distance, or there are other forces that make that other little force to be insignificant.
And that's why it's fascinating to me. Like armchair science or armchair math, I think is really interesting, as a basically what we consider ourselves as science communicators, somewhat public servants, individuals who think that it's very important to make sure that we can translate the complicated science of the sort of ivory tower elite to ensure that the public can fully understand,
Absolutely.
Especially if those scientists aren't doing I think a big enough service to be able to communicate those things. Sometimes you need a translator in between.
And that's why I think that other sciences generally do a better job than math does in terms of promoting its big ideas. I mean, you've got things like the Mars rover going on and the Juno satellite and all these things that's really grabbing the public's attention. And math, not as much.
But the funny thing is, there's so much math in that.
Well, there is. There
absolutely
absolutely is.
But it also sometimes is this struggle as a science communicator, because ultimately that any big picture, big story you're telling, there's something fundamental that if you don't communicate it, that the individuals are kind of missing a basic foundation. And sometimes you just can't. You can't take the time to build from the ground up every time you tell a new science story. But when it comes to math, it really does show you, for example, what a disservice it is if somebody is, let's say, really interested in quantum physics, and then quantum physics is amazing. When you get down to the very small, all the rules change. But it's really hard to know how the rules change if you don't have a fundamental understanding of how the rules should be in classical physics. And so just like you were saying with the Pythagorean theorem, on a flat plane, a squared plus b squared always equals c squared. The minute you draw it on the Earth's surface, you draw it on the outside of a balloon, you start to see changes in the theorem, right? You start to see changes in the proof. It's hard to understand those changes until you know the basics. Right. Until you have the fundamentals.
Absolutely.
And sometimes we want to get ahead of ourselves.
You know, and I mean, from what you were saying to me as earlier in the interview, you said, you know, as a kid, you said, I want to memorize as little as possible. If I know my tables through 5, then gosh, you know, I can derive most of the tables through 10. And that's, in a way, the way mathematicians think, is that there's very little that you have to memorize. You know, there's just really just a handful of concepts in each subject. And then from those, then you just sort of go out and play. Now, if you want to instead, some people will say, well, I don't want to make the initial effort to really understand that concept. What if I just memorize 10 formulas instead? And that's sort of what I try to do in physics and chemistry. And it might get you through a homework or a quiz, but in the long run, you really have to get the big concepts there, and it's so much fun that with just knowing a little bit how much you can get from that little bit.
So what you're saying is that my terrible memory actually served me well in school.
It said that you might have made a great mathematician because you didn't want to memorize a lot. You know, when biology was taught to me in high school, I was like, oh, it's just memorize this, memorize that, memorize that. They didn't do a good job of showing like a big picture that says,
so sad.
You know, and it wasn't until I was well into my college professor years that I finally saw, and it was through things like natural selection of, why do these kinds of insects mate in this way? Oh, it makes perfect sense once you understand their environment and what the nature is trying to make them accomplish.
And so much of that is math too, which is so fun if as a good biology educator to become interested in and understand the foundation of your students. You know, if you were my biology student, I would have really driven the Hardy-Weinberg equation home and really worked on population genetics.
Sure.
And how there really is this like kind of structural balance in the universe. And there's numeracy there as well.
Absolutely. No, I think the more math you know, it just gives you more ways of looking out at the world. It just it's a giant tool in your toolkit of looking at life.
And it's also very impressive. There's also, you know, I get the Mathemagician angle because I mean, I'm watching this TED Talk and I'm seeing the people in the audience losing their minds when you're doing these calculations. It just cannot grasp how you could be doing it so quickly because it's such a non-innate skill.
Sure.
It's the smallest shortcut can make it feel innate.
Absolutely.
So it's the idea is kind of developing these algorithms for life.
Yeah.
It's developing these little machines, these little mental machines where you can just plug in the data.
And ultimately, my goal is, as you say, if you really needed to find out the day of the week, you could just ask Siri and she'd tell you. But it's empowering. It's fun. It makes you wonder, well, why? I mean, I'm hoping that some of you heard me say, well, you take a number from this and that, add them up, and that's the answer. But I hope some of you were thinking, but give me the details. And then after you give me the details, I still want to understand why that would work.
Yeah.
And that to me is so important and also very satisfying. Some of us stop with, okay, just show me the trick and I'm good with that.
Yeah, like I buy that it's not like voodoo,
right?
You know?
And you could teach me how to do it. And like when I first learned this, I learned it from a magic book of all things that I read in high school. And I said, oh, this is really cool. And it wasn't until a year later that I sat down to say, now, why does that work? And, okay. And then once I understood it, I was able to modify it and come up with something that works better for dates in the 2000s. And,
it's interesting because it's true. It's such a scientific way of thinking, a skeptical way of thinking where you're just almost never satisfied. I was taking a yoga class the other day. It was an aerial yoga class, which was crazy. And you hang from these silks in the ceiling and it's amazing. And our yoga instructor was telling the class, sometimes when you spin around, you get very dizzy. And if you start to get dizzy, what's actually happening is that once you've stopped spinning, your inner ear thinks you're still spinning. So maybe go back the other way in order to reach equilibrium. And everybody's like, oh, I never thought about that. That's amazing. But then she stopped there. And I remember going to her after class and being like, do you know why, though, when the movement in your inner ear mismatches what you see, why it makes you feel like you're going to barf? What is that? Where does that come from? It's because your brain thinks you were poisoned. It's because that's a neurological outcome of what happens if you eat like bad berries in the forest.
Wow.
And I think we could go even deeper. We could see what's physically happening in the brain when that. And that's what I love about science. And that's what I love about the fundamentals of science, like math and basic physics.
Right.
Because there's always a deeper understanding that we can gather.
Yeah.
And there's sometimes you're just not satisfied by the superficial answer.
And what I'm concerned about in terms of the educational landscape with all of this emphasis on testing is that it becomes so much more important that, all right, well, what we really got to get good at is making those kids know how to solve a linear equation or memorize the names of the 9 planets or something. We're just going to knock that down until they know, or is it 8 planets? Whatever.
Yeah, it's 8 now. But now maybe there's a planet X, so it could be 9 again.
And so we have to cut out time for the cool stuff. And that's what makes us, you, me, hopefully a lot of our listeners here, people got us interested in science in the first place. It wasn't because we were good at solving linear equations or memorizing the names of the planets. It's because of that cool stuff. And
it's the awe, it's the wonder.
Awe.
And like you
magic.
said, you keep using this incredible term, which I think is so important. It's empowering.
Yeah.
There's something that's so necessary. Whether you're a well-adjusted kid who came from a great neighborhood with amazing parents, or even more importantly, if you didn't have things come easy to you when you were a kid, and if you really struggled with socioeconomic pressures and just fundamental pressures that not everybody struggles with, finding these little oases of empowerment, finding ways to be proud of yourself, to know your worth, those kinds of lessons, I think, carry you so much further as an adult.
Even in little ways, like I've had parents tell me, like, oh yeah, my kid learned the 11th trick and he showed it to his teacher and that teacher bumped him up to a more advanced math class. Now, whether that instantly made them a better mathematician, just because your 11th trick, but it's just the impression that you make on others. It is very that empowerment. And I want to say that it's especially important for women. I mean,
especially in STEM.
I mean, it is so. We have been sending negative signals to women in math and science and engineering in STEM for so many decades. There's no reason why there should be an imbalance of men and women in the sciences. At Harvey Mudd College, where I teach, it's when I started there 27 years ago, it was over 3-1
in the math classes
in the whole school.
Oh wow!
And actually, the guys said it was like pi to 1. Okay, whatever. The girls said, as far as being meeting a guy was concerned, they said the odds were good, but the goods were odd.
Yeah, of course.
And that may still be true today. I don't know, but it was. But we have seen over the years, because we've been making efforts to not stigmatize, not stereotype, that we're seeing the gender balance come much closer to
50-50.
where it should be. Yeah.
And another place we still struggle is with minorities, with underrepresented groups, historically disenfranchised groups.
That's right.
And there's so many reasons for it, cultural reasons, socioeconomic reasons, whether they're reasons that come from home, reasons that come from the community where you live. But it doesn't help that we aren't, I think, doing our due diligence as, I used to work as an adjunct professor for many years before I went into media. We need to be doing a better job, as I'm sure you do every day. I can just tell by your personality and your energy, to help the individual feel like they can control their path,
right.
and like the path is something that's not insurmountable.
I agree. It isn't. We're focused these days on, we measure a school by how many of your students are at this proficient level, and that only serves a small number of the students, because it's really should be about students reaching their potential.
Yeah.
And if you don't quite make it to that proficiency level, it doesn't mean you're a failure.
Yeah, because let's subtract where you were at the beginning from that. Let's look at the improvement.
That's right. Or just as bad, I feel, is the kids that are above the line, and then they get ignored. It's like, well, okay, we just want to stay above the line, but there's, they don't reach their potential, because as far as the school is measured and rewarded, it's like, they've done good.
And especially, you're right, in like primary and secondary school, a lot of teachers, I've heard this complaint that it's the kids that are in the middle that get ignored. The kids who really struggle and the kids who are profoundly gifted get all of the attention.
Or the opposite. I don't want to.
Interesting.
It's just because the kids who are way below the line, well, forget them. Maybe we could convince their parents to leave them at home that day on testing day. And the kids who are way above the line, it's good. You could help us out by helping out the other kids and teaching them. It would be like telling your varsity football players, instead of getting even better and trying to win that championship, why don't you help the junior varsity become better in what they do? I mean, I just wonder if we don't have our priorities straight.
And if our educational system is just not as tailored as it could be. But that said, maybe it wouldn't have to be so individually tailored if we did a better job, as you've said so many times, of making sure everybody gets the fundamentals. Because if everybody started from a similar point, it'd be easier to point out the kids who are struggling and the kids who are gifted. Yeah. But when we're all I can't tell you how many times I'd be teaching a freshman biology class, and I'd be like, did these kids even take biology in high school? They all came from a different place. There were kids who didn't have basic science understanding. And there were other kids who had similar grades, came from similar schools, and somehow knew so much more. It was so strange.
Well, I will say that what really makes the biggest difference, I think, is the quality of the teacher that you have. I mean, you could have two kids from the same school with a different teacher, and one of them is passionate about biology and tells you all this cool stuff and makes your eyes light up, and the other one is droning and says, all right, tomorrow you need to memorize these 50 new vocabulary terms, and
And that translates into the passion in the student in so many ways. I would much rather have a B student who is really interested in the subject matter and thinks it's so cool, than an A student who is like, I don't want to go to class. I don't care. This drudgery. Math is hard, or math is boring, whatever the idea.
That's right. Yeah. That's right. I totally agree.
Fascinating. All right. Well, Art, this was so much fun. Before we go, I want to make sure I'd be doing the listeners a disservice if I didn't close the episode with the same two questions that I ask everybody I have on the show. And they all have different perspectives, and it's absolutely lovely. And I cannot believe I've waited this long to have somebody whose primary focus is math on the show. So I'm super interested in your outlook. So I apologize in advance because these are kind of big picture questions.
Okay.
I want you to answer in whatever context matters for you. So whether it's personal, your family, your life, whether it's much bigger picture, like global even. The two questions are, First, when you think about the future, what is the thing that really keeps you up at night, concerns you the most, really worries you about the future? And on the flip side of that, what are you most optimistic and excited and kind of looking forward to?
Mm-hmm.
I know.
I think the
catch you
thing
off
that
guard.
keeps me that I really worry about
Mm-hmm.
is there is the trend to diminish science if it doesn't serve political needs.
Mm.
I see um, uh, yeah, I see politicians who dismiss scientists and science for things like climate change and vaccines and
Mm-hmm.
medical procedures that I think can be it can really make and break our world. So I I think our country has more of an anti-science strain to it than most other countries, and that bothers me. The other
Yeah.
thing that scares me that I think we is I think the trend in education and specifically teachers
Mm-hmm.
who um, I, we're I don't think we. There was a survey that was done about 6 years ago that showed that 47% of our K through 12 teachers came from the bottom third of their college class, as measured by their incoming SAT scores.
Mm-hmm.
Okay, so in terms and only 20% of them were coming from that top third. And when you looked at all the other countries that were kicking our butts on these international exams,
Yeah.
it was 100% of their teachers were coming from that top third. And I think we need to come to grips with the fact that we need to recruit our best and brightest to to make the teaching profession attractive enough so that best and brightest is willing to go in that direction.
Yeah, because if it's not the best and brightest that's teaching our children, then our children aren't getting the best
That
and
you
brightest.
cannot expect your students to be more passionate or knowledgeable about a subject than the teachers are.
Yeah.
It's especially dangerous in the elementary school years where I'm afraid that a lot of our elementary school teachers, not all of them, not most of them, but enough of them, are math phobic.
Yeah.
And I worry that they pass that math and science phobia onto those students when they're so impressionable.
Totally. Just we have to get through this so that we can get back to story time. We have to, let's just, yeah, I know it's tough, but we'll figure it out, you know?
Let's if we had to do a very short-term quick fix, let's let math be a specialty subject like music and physical education is. We don't ask every teacher to teach music or PE. On the other hand, we do ask everyone to teach math, and I don't think all math teachers are created equal or equally talented. Let's let those teachers who are especially talented and enthusiastic about teaching it to teach that subject a little more during their day and let the others teach it a little less. And it means that you may break away from your peer group for a while to go to a certain room for math like you do for music or physical education. But I think that would do a world of good.
It's interesting, too, because it wouldn't cost any more money.
It wouldn't.
It wouldn't change anything that much.
Honestly, I would rather we pay our teachers twice as much and make our classrooms twice as big to get the best and brightest teachers out there.
Yeah.
I'd rather have an enthusiastic teacher in front of 40 kids than a non-enthusiastic person in front of 20 kids.
Yeah,
you know,
I'd agree.
So that's one thing that keeps me worried a little bit about the
Yeah.
future. Now, on the other hand, there are people who are still getting great education, and those people are doing wonderful things with technology. What's going on in biomedical research is fascinating. I mean, I predict that surgeries 20 years from now will look nothing like surgeries today. I think that's very exciting. You know, it's fun to live in an age where the phones that we carry, our smartphones, are smarter than the phones that were on Star Trek 50 years ago.
They're smarter than the computers that like sent our astronauts to the moon. You know what I mean? It's
carrying
crazy.
in our hands, and that's very exciting. And as long as we don't go, nutso and lose all of our privacy, I think we're. It's very exciting to see what technology is bringing us and allowing us to lead very enjoyable lives, at least for those of us that have the education to take advantage of it.
And I would also add to that, because I agree wholeheartedly that we can't forget that technology is not something that exists because it exists. It's not a fundamental process of nature. Technology exists because people made it. And bright people made it.
And they didn't make it because they were good at plugging through some recipe and learning how to solve linear equations. It's because they understood it. They understood the why behind it, because only those people can take you to the next level and figure out something new.
Yeah. Well, Art, this was so much fun. I have to thank you for showing me some of your tricks. I have to thank you for blowing my mind, for teaching me something new, and for helping me think a little bit deeper. This was great.
My pleasure.
All right. So let everyone who's listening know exactly where they can go to get the book, how they can hear more about you. Are you active on social media? Can they say hi there? Give us all the goods.
All right. Well, go to any bookstore or Amazon to look for my book, The Magic of Math, Solving for X and Figuring Out Y. It's just coming out in paperback this month. So
awesome.
It's not expensive at all. I mean, it's a great investment, and I hope a lot of fun, at least as much fun as a math book can be.
Yeah. And are you active on social? Like if somebody says hi on Twitter, on Facebook?
There's a fan page and there's a Magic of Math, but let me say I give presentations to schools, to colleges, to corporate groups all around the country. So if you're interested in having me come to your event, I'm easy to find. I'm at Harvey Mudd College. That's a name you won't forget, Harvey Mudd. And just look for me there.
Awesome. Well, Art, thank you so much one more time for joining me. And everybody, thank you for coming back week after week. I'm really looking forward to the next time we all get together to talk nerdy.